Okay. The last section of the chapter is chemical nomenclature, or essentially chemical naming. There are a bunch of rules that I'm going to put in place here, but ultimately, the system of naming things is super easy. Okay. You're going to have, when you have a compound, regardless of what it is, there's a couple of different types. So first of all, we're going to come back to this in just a second. There are two types of compounds: a binary compound, which is two different types of elements only. So just two elements, and that's it. Usually a metal and a nonmetal, or two nonmetals, but two elements altogether. Naming is super simple, and you're going to follow those rules. If it's not a binary compound, if you see more than two elements, if you see three or possibly four, we are just simply have to recognize that there is a polyatomic present. The naming is not really going to change. I'm just going to have to look up the name of a polyatomic, and that's pretty much it. So we're going to come back down to this in a second. So our names should always start and go the same way. The NaCl is known as sodium chloride, which you already know, I'm sure. So the sodium chloride portion of this, okay? So the sodium chloride, we are going to take sodium, and the first one is always going to keep its name, okay? So sodium keeps its name. If you have to look up the element, that's fine. If this is a polyatomic, just name it as the actual polyatomic name. But the first one always keeps its name. The second one, on the other hand, is you're going to take the root of it, and you're just going to add an IDE ending. So you're going to take this root, and you're going to add an IDE onto it. So chlorine, this is chlorine, becomes chloride. Okay, so we're just simply going to get rid of the INE and get an IDE. Oxygen becomes, we just cut off the YGEN. Okay, so you're going to know which ones sound correct, but that's it. First one keeps its name, second one gets an IDE ending. First one keeps its name, second one gets an IDE ending, unless a polyatomic is present, and we're going to see that. So let's name every single thing here. We're going to leave space between the two names, okay? So we can fit stuff in there if we need to, because that's where it would go. So first one, let's name it, okay? So again, in fact, if you want to, first one, every single one of these, if you want to give it a try, maybe we'll do one row at a time. Pause it and try to name this first row, okay? And in fact, I'm going to focus on just a handful of different ones. And let's just focus on two right now, okay? And then you can do these. I'm going to focus on a binary compound. So I'm going to take this one. First one is magnesium, by the way, lowercase. Magnesium. I'm going to leave some space in the iodine is iodide, or iodine becomes iodide, IOIDE, iodide. Okay, magnesium iodide. It's binary, right? SRO, is that binary? Yes, it has two things present: strontium, oxide. Oxygen becomes oxide, okay? That's an O. Here we go. Strontium oxide. All right, leaving space in between. We're going to come back to these if we need to. So name these two. Sodium sulfur becomes sulfide. Again, leaving space. Next one, first one keeps its name. I'm going to leave space. Sulfur, and second one gets an IDE ending. Oxide. Okay, all of these have been binary so far. FeO, is that binary? Yes, it is. First one keeps its name. Second one gets an ID ending. Great. Moving on. We're just going to keep going. First one keeps its name. It's binary. Iron. Oxide. Okay. And we'll talk about these. These two right here are both called iron oxide. So there's a problem. They're different, and we need a way to differentiate those, but we're going to come back to this. Okay. How about these two? So these are both not binary. Okay. First one, is the first thing a polyatomic? Is the metal a polyatomic? It's not. It's going to keep its name, iron. This is where my polyatomic is. It is hydroxide, hydroxide. Okay. Next one, find the polyatomic. There it is. Potassium. Nitrate. I know that's a nitrate. Okay. And again, we're going to add more to some of these, but for the most part, we're going to keep naming them. So do this last row, name this last row, and I'm going to do it right now. First one keeps its name. Carbon oxide. Vanadium chloride. Silicon or silicone oxide. And then finally, boron fluoride. Again, first one keeps its name, second one gets an IDE ending. If you have a polyatomic, okay, if we have polyatomics, we just simply rewrite what their name is, oxide, hydroxide, nitrate. And that's it. So with that said, this is the start. Every single one of these, first one keeps its name, second one gets an IDE ending. In between, there are a couple of cases that we have to add a little bit more. So like I said, iron oxide, these are both iron oxide, but they can't be. We have to have a way of differentiating FeO from Fe2O3 because they are different compounds. They have different ratios of iron to oxygen. So we have to have a way to differentiate these things. And so first we ask the binary compound, we add a polyatomic name if it's present, okay? The next thing that we need to do is we need to decide, and this is the hardest thing to do in all of these. First of all, do you have a metal present? And we recognize metals as the left-hand side of the periodic table. If you have a metal present, you have to ask, is that metal fixed or does it have a variable charge? And you're saying, well, I have no idea. Well, it turns out there is a small list, and this is the list here. These are the fixed metals, metals with fixed charges. And it's a pretty short list because what we have is if it's in group 1, if it's in group 2, or if it's any of these starting at aluminum, you create this little staircase here. So starting at aluminum, right? Aluminum, gallium, zinc, cadmium, silver. So it just kind of creates this little staircase here, okay? Notice that aluminum is in group 3. It has a 3+ charge. These are 2+, and this is 1+. So starting at aluminum, these are all the fixed charges along with group 1 and 2. So group 1 and 2 are +1, +2. Aluminum and gallium are both +3. Zinc and cadmium are going to be +2. And then finally, silver is going to be +1. Those are fixed. They're always going to be those charges. So if I say aluminum, the reader knows that the aluminum charge is always +3. I don't have to give any additional information. If it's not one of these, so first of all, if it is one of these, group 1, group 2, aluminum, zinc, cadmium, gallium, silver, we're done, okay? There's no further naming needs to happen. So let's go through this list and let's decide, okay? Do I have a metal present? Yes, I do. Magnesium is a metal. Is magnesium in group 1 or group 2, or is it one of the special ones, aluminum, gallium, zinc, cadmium, or silver? It's in group 2. That is the name. That thing is done. We are good to go. Next up, strontium oxide, okay? Is strontium in group 1 or 2? Because, well, first of all, is strontium a metal? Yes. Is it in group 1 or 2? Yes, it is. Strontium's in group 2. Therefore, it is fixed. The name is done. Sodium, is it a metal? Yes, it is a metal. Okay, I guess I should do M. That is a metal. Is sodium in group 1, 2, or is it that staircase over by aluminum? It's in group 1. We're good to go. That thing is named. Next up, is sulfur a metal? No, it's not. This is a non-metal. We'll come back to this one, so we're going to have to see that one. Okay, back over here. Is iron a metal? Yes, it is. Is it in group 1, 2, or the staircase? No, it's not. We need more information. We're going to talk about that in a second. Same with this iron. Same with this iron. Potassium, is it a metal? Yes, it's a metal. It's in group 1. It is done. It is named. Okay. Next up. Carbon oxide. Carbon is not a metal. So we have a special naming system we're going to talk about later. Vanadium is a metal, but it is not in group 1, 2, or that staircase. So that one needs a special naming system. Silicon. Silicon is a semi-metal, but it is not a metal. So it's going to be used the other naming system. Same thing with boron. So all of these, so we have named everything that has been boxed so far. Okay. So if we have a metal and the charge is not fixed, okay, so the charge has not been fixed, it's variable, we have to tell the reader the actual charge. And we do that by using a Roman numeral. So what we're going to do is if I have, let's say, iron 2 plus, we're going to call that iron. And in parentheses, I'm going to put iron 2. Okay, and with a Roman numeral saying that thing is the metal that I have has iron of 2 plus charge. Let's say that I have cobalt 4 plus. I would call this cobalt parenthesis 4, and that's it, cobalt 4 plus. So the Roman numeral is always going to tell me the charge. So I is equal to 1, 2, 3, IV is equal to 4, V is equal to 5, VI is equal to 6, VII is equal to 7, and that is as high as you'll need to go. Okay, so if you didn't know Roman numerals, there you go. All right. So now we have to go back through our list and we have to decide the charge. And now this is where things get, there's a little bit more information. So this was a non-metal sulfur oxide, iron, iron, iron. So these right here, how do I determine the charge of my iron? Well, what do I know? Since I don't know the variable charge, I do know the other thing. So if I look at iron oxide, okay, I know that iron has a charge of -2. Okay, and in fact, I'm going to do this over here just because it's worth teaching this way. So here's my iron oxide. Above it, I am going to put the individual atom charges. Okay, and I'm going to fill out every one I know. So group 1, group 2 are always +1, +2. We know that oxygen is -2. The whole thing is neutral, as all of these are, so it's going to be equal to 0. I have oxygen at -2. What does the iron have to be in order to essentially make sure this whole thing is neutral? Iron is +2 in this case. So iron 2 oxide. There we go. This thing has been named because it's iron 2 plus. How about this one? Well, I have a total charge of -2 for the oxygen, but there are 3 of them, so the total charge is -6. That means that I'm going to need +6 in order to make this whole thing neutral. And there are 2 irons, okay? So 6 divided by 2 is going to give me a +3 charge. This is iron 3 oxide. How about this one? I know hydroxide itself is -1, and I have two of them. So overall, I have a -2 charge from the hydroxide. The iron has to be +2 in order to make this true neutral. So this is iron 2 hydroxide. Okay, potassium nitrate's done. Not a metal. Vanadium. I know chlorine is -1, and there are 5 of them. So what has to go in that parentheses in order to make this true? +5. So that means that vanadium itself is +5 because it needs to neutralize everything. So vanadium 5 chloride. There we go. That one has been named. And that's it. So we're done with all of these. The only ones we have left are the non-metals. So first thing, name it. First one keeps its name. Second one gets an IDE ending. If it's a fixed charge, group 1, group 2, aluminum, gallium, zinc, cadmium, silver, in that little staircase, you're done. If not, if it's a metal, it's variable. You have to tell the reader, is it iron 2, iron 3, whatever it happens to be. You have to give them the charge of the metal itself. And the last thing, if it's all non-metals, okay, sulfur, oxygen, boron, basically any semi-metal or it's all semi-metal or non-metals, we're going to use a special naming system. And actually, this is significantly easier. We are just simply going to, the ones that you probably know, CO is carbon monoxide. And CO2 is carbon dioxide. Okay. When we have these, again, first one keeps its name. Second one gets an IDE ending. But this time, what I'm going to use is I'm going to tell it mono represents 1 oxygen. Notice that I do not have mono here, okay? But just having carbon indicates that I have 1. So this is the only exception is we never put a prefix of mono for the first one, right? So that means I have 1 carbon and I have I have 2 oxygens, okay? What would you name S3O4? Okay, again, first one keeps its name, sulfur, oxide. I have 3 sulfurs, so I have trisulfur, and I have 4 oxygens, tetroxide. And we actually usually don't run vowels into each other, so tetroxide. 3 sulfurs, 4 oxygens. That's it. We just simply add the prefix. We never add mono after the first one. So mono never before first element. Okay. What would you call this? Water, but we're going to call, again, first one keeps its name, hydrogen and oxide. We're going to call this dihydrogen monoxide. Never run 2 O's into each other, just lop off that O. Dihydrogen monoxide. That's the true proper name for water. So with that said, and these are our list of prefixes, name all of these. Dicarbon, and I'll use red because that's what I was doing. Dicarbon tetroxide. Okay. 2 carbons, 4 oxygens. Silicon, we don't need mono for the first one. Dioxide, I have 2 oxygens. Again, if it's all nonmetals, we have to add prefixes to tell the reader. Same thing, boron, no prefix, trifluoride. Okay, and that should do it. Oh, up here, last one. Trisulfur pent oxide. Again, 2 vowels run into each other. Generally, we just lop off the A or the, but whatever sounds right. I'm not going to hold you over the coals for it. Okay, we've named everything. Again, first one keeps the name, second one gets an IDE ending. If we ever see a polyatomic, we just name it what it's named. If it's a metal, if it's fixed, we're done. If it's a variable metal, determine the charge and add a Roman numeral to tell the reader what the charge is. And if it's all nonmetals, just prefixes, and that's it. Okay? All right, great. So with all of that said, the last thing that I want to take a look at is the following. So we are going to convert the following names to compounds. I'm going to do the first row and I'll let you guys do the second row, and you can fill out the elements, fill out this table. So fill out this table. I'll do the first one or two in this table. In fact, I'll do a couple of these and then we'll go from here. Okay. Sodium oxide. So I know I have sodium and I have oxygen. Okay. I know sodium forms a +1 charge and oxygen forms a 2- charge. And now I just create a compound out of these. This 2 is given to sodium. This 1 that's not written is given to oxygen. So Na2O1. So Na2O. Done. Okay, write out the compound, determine the ion, and go from there. Let's take a look at copper-2 sulfide. Copper and sulfur, the 2 part of this basically says it's a 2+ charge. And we know sulfur is in group 16. It's going to be a 2- charge. That 2 is given to sulfur. That 2 is given to copper. So Cu2S2, but that can be simplified to CuS. Done. Okay. So gallium chloride, silver phosphate, go ahead. Ammonium hydroxide, what else do we want? Let's do the disulfur. Again, because this is a nonmetal, the prefix indicates, it's just telling me how many there are. These are easy. S2 pentoxide, S2O5. Right, the prefixes, whenever you see a prefix, you should do those first, right? How many do you have of each? Let's see. Let's take a look at, this one is the last one I'm going to look at. Silver, Ag. It's not giving me a Roman numeral, it's a metal, so I have to know the charge. It's actually one of those special ones. It has a +1 charge. And I know phosphate, Ate, indicates it's a polyatomic, PO4, and we look it up and it's PO4 3-. So I'm going to put this in parentheses. This 3 is given to the silver, and that 1 is given to the phosphate. So 1 phosphate, 3 silver. We end up with Ag3, PO4, 1. And again, if I only have 1, Ag3, no parenthesis, PO4. Done. Okay, so this is proper for that one. Good. So try those other 4 and yeah, give those a go. And now finally, this table, calcium and fluoride, what compound do you make? What's the name? And so actually, I'll just let you set you loose on these, similar to what we did above, okay? By the way, you can call it, so M magnesium and sulfur, or you can show the ions if you like, whatever you like to do. But yeah, so do this and we'll work through it in class. All right, that should be it for the chapter. We'll move on to covalent after this or next chapter.